everyone, this is your boy Neil Gonzalez, WeatherX45, and I am going to tell you a topic of how convection relates to plate tectonics. Now, if you're thinking about this question, what you should be thinking in your most academics of thinking and brainstorming is what are convection currents? So let's go to our lesson topic on my seat, shall we? Come on, let's go, follow me. So here is our lesson topic that we're going to start right now. Refreshing. Basically, convection currents occur when the involvement of magma, lava, igneous rocks, and sedimentary rocks, which is part of the forms of mountains that are basically formed from the plate tectonics, that mostly forms on solid format rocks. There are three major convection cycles. 1. Geological solid rocks. Basically, geologists, what they do is they take information from different inferences that they predict by doing tests and unknown rocks that are been found. So what geologists does, basically what they do is they test and see the timeline, and they tell you everything of when the rocks have been formed for thousands and thousands of years from over the timeline of Mother Nature's creation. What's really interesting in the topic is that geologists basically studies and learns new things about rocks, that and underground in formation of rocks there are fossils living inside of rocks. And why is the reason for that? The reason is because during the dinosaur times and for many and thousands of years, there was many changes and involvement of the evolution of the Earth. And geologists were very like tech smart. What they did was they took stuff and information from computers. They measured the rocks formation. And what's really interesting is that what do they first measure? They first measure sedimentary rocks to igneous rocks. Now, what is igneous rocks? Igneous rocks are basically molten, very extremely hot, just hot, very hot layer of rocks. It's very extremely hot. It's even hotter than a boiling of water, even hotter than anything you could compare from any typical acid, period. The current temperature for an igneous rock is about 2,800 degrees Fahrenheit. 2,800 degrees Fahrenheit. If I ever touch and lay a hand on the igneous rock that's basically formed by lava, if I ever touched it, I would be definitely melted down. There is no way for you to be closer to the igneous rock. Any igneous rocks are the forms of the volcanic eruption from the convection cycle, that when two plates move around from the flowing convection currents of magma that moves and changes the evolution around different kind of mountains. Here's the good news. What stops mountains from growing and growing higher is that there's weathering and erosion. And what is erosion? Basically, erosion is when you have a rock that is basically sitting near water high tides of pressure. Water is very dense. Water is about 1.0 cubic of so much force of water. It's very heavy. Water is extremely heavy. So, erosion really happens when you have weathering. Let's say, for example, rain, heavy rain, a storm, winds. Winds cause erosion. What is the form of erosion? How does it affect mountains? Basically, erosions, it breaks down mountains from growing to a big, enormous formation of rock that can just go to the layers. What's really interesting is that volcanic eruptions, when a volcanic explodes and erupts, ashes starts to grow. You start to get a new mountain that forms. And this is what I learned from Mr. DeCanier's class. What I really learned is that we have basically a baby mountain, which is a volcanic eruption, and we have the adult mountain, which is basically the biggest mountain that's ever formed, ever made. That is the second step after when the volcanic eruption is finished. You have lava that's basically coming out from the pressure, the big pressure that's condensing with amount of heat around the atoms. The atoms are basically coming up and being excited, and they're compacting, being excited. And what causes that, so much pressure builds up, and it bumps into like a big giant of steam ash. We have different kinds of igneous rocks. There's two different types of them. One is extrusive, and two is intrusive. What is an extrusive and an intrusive igneous rock? An extrusive rock is basically when lava and magma is basically rocks that are formed from magma and lava, and whatever you want to call it, like a hot, boiling, liquid hot magma that basically just builds up igneous rocks. And it just forms this interesting color. Scientists had studied that when lava, when it cools down, it becomes this black, soft, greasy feel. According to the Earth Science Reference Chart, which is really interesting, the igneous rock is a form of lava and magma when it cools down. Basically, that's the extrusive igneous rock. It's when lava, liquid hot lava and magma basically comes out of the volcanic eruption. And what happens is when the volcano grows bigger, mountain grows, and once it goes higher, because remember, when you're going higher for different kind of atmospheres around the Earth, it gets colder. And the reason why is because basically it's science. When you go all the way up to the atmosphere, all the way up, let's say you're leaving miles away from Earth, it's going to be very cold. So what happens to the lava that basically grows down? It cools off. Or it can cool off from weathering or from wind. And then it forms into a greasy, igneous rock of basically cooled liquid of magma. That's it. And what's really interesting is that it's like a black igneous rock that's made of like glass, and basically it cools off because there's so much condensed pressure from the igneous rock. That's an extrusive igneous rock right there. Now, an intrusive igneous rock is when it's formed beneath the Earth's crust. It looks like a crusty, hot, crusty, compacted together of like liquid magma that's basically dried in there, and there's so much condensed pressure that's pushing it in, and it's just a really condensed pressure, and that's around the involvement of the convection current. The second convection currents of the three major cycles is known as the hydrosphere. The hydrosphere is basically part of erosion, because when you have high tides, let's say you're having a rip current that's coming and it's going towards the area from the rocks. What happens is, when water and force, gravity, so much water and pressure bangs, just think of it as a hammer that's hitting the rock every single year. Every single year, nature keeps hitting the rock. So basically, erosion happens when you have a big water wave, and it's basically rough, and it smashes into the rock every single year, and it breaks down. That's erosion. Another one of erosion is rain. Rain comes down, then wind, it breaks up the rock, and what happens is, usually, rocks could just collapse, and then the new evolution forms again. We get convection current again, and then we get erosion, the mountains break down, and then it comes back again. Erosion, weathering, it comes then, and then it just, a big eruption happens, big mountain forms, erosion brings it down, rocks come down, Boom, then a new convection current comes. It's a cycle. Basically a cycle in an environment that basically happens. That's why it's part of the plate tectonics. And plate tectonics are basically from seismic waves when there's pressure. There's basically pressure in the two plates. One that's rubbing up against each other, one that subducts, divergent plate. You have one that's basically that pulls away, a subduction zone, and you got one that pulls away from each other. There's different types of ones. There's also like different kinds of falls, rubs against each other. So much different types of pressure made from the mantle. The mantle is the king side of the side that basically moves the plates around, changing the convection current. Convection current is the biggest important message for all of you. And the reasoning why is because convection currents are part of earthquakes. Why is convection currents part of earthquakes? The reasoning why is because when you have a convection current, basically liquid hot magma is basically moving on the crust. And what makes that crust do, it moves. And then the one that's less dense or one that's more dense, the one that's more dense subducts. The one that's less dense, it goes up. And then it goes subduction zone, it goes down. And then this one overrides. It overrides. Then boom. And then that's when you get mountains. Now, when you have plates that move away from each other, that's a form of volcanics. Volcanoes. When plates move away from each other, that means mantle is basically coming up from the center of the depression, known as the depression collapse. The depression collapse is basically the center of the convection current, where the two plates, the pressure pulls away from each other, and then you get a form of volcanoes. And then what happens is you get an eruption, igneous rock forms, and then erosion comes back again, and then boom, the new cycle comes again. Are you getting this now? Another interesting topic that I want to really bring, which is going to really make you excited, is that the atmosphere is also part of the three major cycles of convection currents. Here's the reasoning why, and I already told you why, and if you listen to one of my words that I just said in the previous one. The reasoning why the atmosphere is part of a convection current is because mountains, they usually grow so big. And when they grow so big, thanks for weathering, weathering allows the rocks to break down. Without weathering, the earth will become a big mountain world. Trust me. Without weathering, without erosion, the rocks of mountains will become super mountain earth. And that's a bad problem. But thank God that does not happen, because Mother Nature had a coincidence to bring weathering and erosion from avoiding that problem. So what happens is, if the mountain keeps growing, and let's say the atmosphere is not cold at all, it's just hot, nice, and it's not, there's no wind, right? So what happens is the rock keeps growing and growing, growing bigger, and then boom, it hits the space. What happens is the water, the oceans, this is just what happens if there's no weathering and erosion. If there was no weathering and erosion from the combat for the convection current, the whole entire Earth will have no oceanic water at all, period. The reasoning why is because mountainous forms. Basically, the oceanic crust starts to dry out, it becomes a mountain, and then boom, it grows. But thanks for Mother Nature's coincidence, we got weathering and erosion. Well, without it, we wouldn't be living here. The reason why we wouldn't be living here is because, like I said, there will be no oceans at all. It will basically dry the whole entire ocean because it's forming a new landmass. Think of it, for example. I'm going to give you a hint to give you a helping little study. You have the water, and when you have a convection current, basically what happens is the mountain starts to climb up. It starts to climb, and then the ocean starts to get sucked up, and it goes down, and then it sinks down, and then it goes into the crust, and then boom, you get a mountain in this form. But is that going to really happen? No. Weathering and erosion keeps going. Now, let's look at, here's the interesting topic. Have you ever heard of that bridge from from the island, the tip of the island of South America, there was a bridge, a beautiful rock bridge. People used to travel in it, but it's no longer there. And the reasoning why is because erosion kept slamming. It's not going to just leave it there and say, oh, I just made a bridge. I'm just going to leave it there. Nature does not do it like that. Nature keeps doing the things that they have to do. It's basically an involvement of the citation of what she works. Mother Nature really does her job of what she does. She does it constant. She doesn't just leave something that what she did was art. That's not how it works. Basically, erosion keeps going. Cracks the rocks, then we get a convection current. It's a cycle that keeps going and around. And that's why it involves the plate tectonics. Plate tectonics are part of it's also part of landslides. Think of landslides. And this is a perfect example. Landslides are part of erosions as well. Landslides usually happen when, let's say, you have a rock that's basically not stable correctly. There's a crust that's basically not stable. What happens to that? It gets less dense. And then, boom, it breaks down. Why does it break down? The reason why it breaks down is because there's no stableness. And then that's the erosion. It comes back. Mother Nature does interesting stuff. She basically forms erosion underground. She could form erosion on the atmosphere, because the atmosphere, when you go to the stratosphere, thermosphere, exosphere, or whatever you go up to the space, it gets colder. There's no way for a mountain to just basically climb over to space. Weathering always happens. Wind, hurricanes, storms. Lightning is also part of erosion. Because think of it, if a lightning hits on a rock, what happens is you get a dust fire. Fire forms from lightning, right? So that is the convection current of the cycle. Hope you guys liked this video. I hope that you enjoyed the topic. And Eudos to the Studios. If you want to see more videos, click the subscription button. Subscribe. Also follow me on Facebook. And follow me on Google Plus on Neo Gonzalez, the King of Comedy. And also on Neo Gonzalez, WeatherX45. Peace out.